Hello and welcome to this lesson in which we will see some of the other features of PrimeWin, particularly related to transformations. So one of the interesting things that you can do in PrimeWin is to perform a principal component analysis. Now it's beyond the scope of this video to talk about the theoretical background of principal component analysis. So all I'm going to do is just to show you how it can actually be performed. But before I proceed, let me just mention the following about principal component analysis. In a multispectral data set with multiple bands, that is, it is commonly seen that there is a very high degree of correlation between bands in a satellite image. What principal component analysis does is to reorganize this data so that this data is no longer correlated. The end result of the principal component analysis is that we get a few principal components, and the interesting part is that the principal component analysis concentrates all the information in the first 2 or 3 components. So in summary, the principal component analysis, or PCA, transforms an original correlated data set into a smaller set of uncorrelated variables that are actually representing most of the information that was present in the original data set. Principal component analysis has a lot of application in natural resource monitoring, in terms of change detection, wetlands, fire, and so on and so forth. So how can we perform principal component analysis in PrimeWin? Well, I have my Bhopal image in the viewer, and to perform principal component analysis on this multispectral data set, I just go and click on the transform button, and right up on the top you have the principal component option. So we're going to go and click on this option, and a dialog appears. So we have to provide the input image file. I'm going to click this and go and pick up my Bhopal file. Recall that the Bhopal IRS data is having 4 bands. Next up, we need to provide the output file in which we are going to store the results of the principal component analysis. So I'm going to click on this, and I'm going to give the name of a file. This can be any name, so I'm just saving this. And one of the important things that we need to notice here is that the principal component analysis will result in principal components, and this little checkbox here asks you how many components you want to save in the output file. So recall that most of the information is present in the first 3 components, so we are going to go ahead with the default of 4. That is, we'll store 4 components in the output file. So all you need to do now is to just press apply. So PrimeWin does the job, and you can then go to file and open, and let us pick up the file that we have just created. It opens up a viewer, and just like before, we will choose which components we will assign to which guns. So recall that gun number 1 is the red gun, gun number 2 is the green gun, and gun number 3 is the blue gun. So in this particular case, the default is assigning the principal component number 1, which is now appearing as band 1, to the red gun. Principal component number 2, which is now appearing as band 2 in the PCA image, we are going to assign this to the green gun, and the principal component number 3, which is now appearing as band 3, will be assigned to the blue gun. So we will just click here, and we have our principal component image. We will right click and apply a stretch, maybe a histogram equalization stretch, and you can now see the principal component image. The interpretation of this image is beyond the scope of this video, and the viewer is encouraged to read up on the theoretical background on how to interpret PCA images. But it is important to note because we have assigned the principal component number 1 to the red gun, the red hues are from that component, and likewise the blue and the green hues are coming from the other components. So this is how you can create a PCA image in PrimeWin. Let me also quickly point you to one of the interesting features of PrimeWin, that is image registration. So you can just simply click on this button, and I'm not going to do this, but I'm just going to point you how it can actually be done. So you can opt for the first button, which is GCP collection. So that is ground control point collection. So you can click on this. PrimeWin will provide you with options. So in the first option, you can actually open the uncorrected image, a viewer will open, and in the second one you can have a corrected image which is already geo-referenced, and then using both the images you can collect your GCPs. So you will click on one image, point to a ground control point, and then identify the same ground control point on the corrected image. And once you have collected enough points, you can save this as a GCP file and then come forward and fill this dialog, providing the name of the GCP file, the input uncorrected file, the reference corrected file, and finally an output file. So when you click on the perform button, the image will actually be registered. But one final point is that there is an interesting tool right here, projection parameters. So it has all the states of India. So you can click on a particular state and you can choose a projection. Two options are available: Lambert conformal conic and transverse Mercator. You can enter the false easting and northing in these boxes, and you can just press compute projection parameters. So you can get projection parameters that you can use for registration. So this is an interesting tool. Thank you very much for watching this lesson, and hope you can use PrimeWin for image processing tasks. Thank you.